Chalo. I guess we did it till preparation of potassium dichromate, if I'm not wrong. Yeah. Hmm. Today we have to start it with KMnO₄. Okay. Hmm. Okay. So we had completed with preparation of potassium dichromate. I'll revise it quickly. Okay, I'll revise it quickly. As I told you, remember from the statement, yes, your potassium chromate, your dichromate, sorry, what is the oxidation state of chromium in potassium dichromate? Yes, Archana, Prashanti, and what is the Gopinath? Good evening. What is the oxidation state of chromium in potassium dichromate? Correct, it is nothing but +6. Perfect, it is +6. So what happens? We are preparing potassium dichromate. We are looking from the very basic step. Yes, from where we start, we take a ore. Yeah, we have seen what are ore in the metallurgy chapter. Correct. So we are preparing potassium dichromate from directly from the ores. Okay, like if I ask you, how do you make rice at home? Okay, so you are starting from a farmer has, put seeds in the soil. He has taken out the rice after harvesting it. Yeah, we are starting from there. Okay, it depends upon what is the marks of the question, isn't it? If I ask you, how do you prepare rice, answer me for 10 marks, then you will write the whole birth of the farmer also there, isn't it? Yeah, Sarjana, isn't it? Then if it is for 10 marks, you will start from the birth. Once upon a time, there was a farmer who born on this date, yeah, who was walking to the farm. Yeah, you will start from there, isn't it? So similarly, this preparation, we are starting from the ore. Okay, we are starting from the ore. Okay, so which ore that we take? We take the chromite ore. In the name itself, we know it is a chromite. Yeah, so in the chromite ore, what do we have? Good evening, Kevin. In the chromite ore, we have Fe, we have Cr both, but do we require Fe? We do not require Fe. So what do we do? In the first step, we remove that Fe by treating it with base. Yeah, we remove that Fe by treating it with base. We remove that as a chromate. What we get is a chromate. So from chromate, first thing what you have done, you have converted chromite ore to chromate. Then in the second, chromate to sodium dichromate. And in the third step, very easy, very simple. We do not require sodium dichromate, isn't it, Sarjana? We require potassium dichromate. So simply we treat it with KCl in the last step. Yes, that is the salt. And obviously Na has more affinity towards Cl. Yes or no? Yeah, Na has more affinity towards Cl. So you'll get NaCl. Yeah. It is same like when I ask you, do you like chemistry or biology more? Yeah, you have more affinity towards biology, isn't it, Kevin? Yeah. Hmm? So no matter how much I dance over here, please learn chemistry. Please learn chemistry. But if you have time, you will be more focused on biology because you have more affinity towards biology, isn't it, Kevin? Yeah. Hmm. Okay. So same thing over here. Chlorine has more affinity towards sodium, obviously. So sodium will come out from there. We'll go with chlorine, you'll get sodium chloride. Now they have affinity. Now little bit, like it is like you want some marks. Yeah, you want some marks. A little bit of chemistry is remaining. So potassium do not have any option. Yeah, so potassium goes and, yeah, sits with chromate, your dichromate, and this is how you get the potassium dichromate. So first step was, we had taken chromite ore which contained Fe and chromium both. We have removed Fe by treating it with base. We have got chromate. Then that chromate we converted to sodium dichromate, and that sodium dichromate we converted to potassium dichromate. Is it clear? Yes. Is it clear, Anmoldeep, Kevin, Prashanti, Gopinath, Sarjana, and is it clear? This is where we stopped in the last lecture. This is where we stopped in the last lecture. Yeah. Then we started with the properties also. Yes, we started with the properties also. I had asked you potassium dichromate. Yes, we had looked at the diagram. How does potassium dichromate look like? Yeah, everyone has seen the potassium dichromate, isn't it, Kevin? You've seen the potassium dichromate. Yeah, Kevin is thinking to make his hair color of potassium dichromate, isn't it, Kevin? Yeah, and making reels on Instagram. Yeah, he will start making, like, use the potassium dichromate on his hair, will grow it all orange. Yes, yeah, and will dance in front of camera and will make the reels on the Instagram. Isn't it, Kevin? That we have to do. If we do not clear the NEET, we have to clear the NEET. Yeah. Hmm. So over here, yes, it is orange red. Yeah, it is orange red, beautiful looking, solid. Yes, it gives the positive chromyl chloride test. We have seen what is chromyl chloride test. I have told you that it is a test when you have, like, it gives the confirmation of chlorine. Okay, and K₂Cr₂O₇ is used as a catalyst over there. Okay, then there are various other reactions. This is important. Oxidizing character. Yes, potassium dichromate is a strong oxidizing agent. You learn that in your organic chemistry. Okay, you learn that in the organic chemistry that your potassium dichromate is a very strong oxidizing agent. Okay, then there are these few properties, few tests that I want you to show. Okay, I wanted you to see this because ultimately, everything is dependent on the oxidation state. You remember the stable and the common oxidation state. Every answer ends over there. You learn it in the reaction part, but look over here. Every answer ends over there. For example, look at this. I have K₂Cr₂O₄. Okay, then if I heat it, okay, if I heat it, it will convert into K₂Cr₄O₄, which is nothing but a chromate. Yeah. So chromate. So what is the oxidation state again for chromate? CrO4 2 minus. CrO4 2 minus. What is the oxidation state? What is the oxidation state? It is also +6. Yeah, you are heating it. No oxidation, no reduction. You are just heating. It breaks down and gives you potassium chromate. Now your dichromate is orange, chromate is yellow. Orange, yellow. Yeah, orange, yellow. So Kevin, potassium dichromate on hair and your potassium chromate on teeth. Yeah, green, yellow, not green, sorry, orange, and your teeth yellow, and will dance on the reels. Yeah. Okay. So remember, okay, that potassium chromate is yellow and dichromate is orange color. So remember this. I've told you to remember it. Okay. Not to make fun of Kevin. I want you to remember potassium dichromate is orange in color. Your potassium chromate, if you want, write it down. Chromate is in yellow, dichromate is in orange. Okay. So see, if I heat it, what I am getting? Potassium chromate. If I treat it with alkali, again, Kevin, what I am getting? Potassium chromate. If I treat it with weak alkali, strong alkali, no matter what I am getting? Potassium chromate. Same thing over here. Yeah. And again, now simple reaction. I am just reversing it. Yeah. If I treat potassium dichromate with the base, I get the chromate ion. So how can I reverse it? If I treat chromate ion with acid, I'll get the potassium dichromate. Look over here. If I treat potassium chromate with acid, I'll get the dichromate. So orange, yellow, yellow, orange, orange, yellow. Yeah, are you getting it, everyone? Okay. So remember this. Dichromate is orange, chromate is yellow. Yeah, chromate is yellow. Is it clear? Okay. So below pH 4, it is like in the acidic, we have a orange color. In the acidic medium, we get the dichromate. In the basic medium, we get the chromate. Yes, write it down if you want. In the acidic medium, you get the dichromate. In the basic medium, you get the chromate. So acidic medium, you get the dichromate. Write down this. Acidic, you get the dichromate, and in the basic, you get both chromate. You get the chromate. Come on, write down the last part and then in the chat box. And please, whatever I am highlighting, if you are not writing in the class, after the class, I am telling you, while doing revision, it is your duty. Please write down those reactions. Yeah. You have to do the revision. Without revision, not possible to clear NEET. Shallow. Let us go ahead. Let us go ahead. Now, after potassium dichromate, now these are some of the tests. Okay, just go through it afterwards. I'll shed some light on it later on, but let us complete our syllabus first. Now, look at the structures. Look at the structure. So, your chromate ion, this should be chromium. This should be chromium, not oxygen. This should be chromium. So, this is your chromate ion. Yeah, chromate ion. This is also tetrahedral. Yeah, and this is also what is happening. Two tetrahedral units are joined. Two tetrahedral units are joined. So chromate ion is what color? It is in yellow color. Yeah. Dichromate ion is in orange color. That you have to remember. So two tetrahedral units you have joined. If you join two tetrahedral units, you get the dichromate. If you have one unit, you get the chromate. Simple as that. Yeah. Simple. Now look at the reactions. Look at the reaction. What happens? Like this is a proof. This is a proof that the potassium dichromate is an oxidizing agent. Look over here. Everyone focus on the screen. Kevin, look over here. So I have Cr₂O₄ 2 minus. You have already calculated the oxidation state of Cr₂O₄. What is it? Yes, oxidation state of Cr₂O₄ 2 minus. Quick. Correct, and it is plus 6. Now over here Cr plus 3, what is the oxidation state? Obviously it is given over there, plus 3. Now Fe plus 2 you have. Now you tell me Fe plus 2 to Fe plus 3, is it oxidation or reduction? Sarjana, Kevin, Angmoldeep, Kirtini. Yes, Kirtini, I am turning on the camera, giving you the warning. Yes, Sarjana, and what is the oxidation? What is it? Prashanti, is it oxidation or reduction? Fe2 plus to Fe3 plus, what is happening, Sarjana? Is it oxidation or reduction? Yes, Kevin? Correct, Anmoldeep. See, remember like this, Kevin, if you ever have doubt, it is oxidation or reduction. What is the sign over there? It is plus 2. On the right hand side, it is plus 3. You have to make all of them balance with only help of electron. Okay, electron is minus 1. Okay, so over here it is plus 2, over here it is plus 3. So if I add minus 1, it also becomes plus 2. Yes or no, Kevin? So right hand side electrons are there. That means what, Sarjana? It is oxidation. Correct? It is oxidation. Are you getting it, Kevin? Yes, it is oxidation. Similarly, plus 6 to plus 3, what is it? Plus 6 to plus 3, is it oxidation or reduction? Yes. Is it oxidation or reduction? Correct, Sarjana? Yes, correct, Anmoldeep, Kevin, and is it oxidation or reduction? Correct. It is nothing but reduction. So just now, Kevin, we have proved that your Cr₂O₄ is oxidizing Fe2 plus, but itself it is undergoing reduction. What do we call them, Sarjana? It is oxidizing the other element, that is Fe2 plus. Itself it is undergoing reduction. Such elements or such agents, what do we call them, Sarjana? Correct, and we call them as, correct, Anmoldeep, we call them as oxidizing agents. We call them as oxidizing agents, and that is what we have just proved, that yes, Cr₂O₄, that is K₂Cr₂O₄, is your oxidizing agent. Is your oxidizing agent. Are you getting it, everyone? Yeah. So what is important? I will tell you a hack for this. I will tell you a hack for this, Anmoldeep. Very important, you should know the common oxidation state. You should know the common oxidation state. Like Fe plus 2, you should know there are two common oxidation states, plus 2 plus 3. It cannot get in plus 4. So no matter what oxidizing agent you use, your Fe2 plus will always go in plus 3. Are you getting it, everyone? So please, you have to work on common oxidation states. You have to go through it. Okay, that will solve at least 80% of your questions. You should know common oxidation states. Okay, common oxidation states, Kevin, very, very, very important. Okay, so just now over here same thing is given. See, I minus, if you treat it with Cr₂O₄ 2 minus, it will go to I2. H2S, you will get the sulfur precipitate. Sn2 plus, you will get Sn4 plus. Fe2 plus, Fe3 plus. This all, everything, what does it prove? It proves that yes, your Cr₂O₄ 2 minus, that is potassium dichromate, is an oxidizing agent. Is it clear, everyone? Come on, give me yes or no. Is it clear? Is it clear? Okay, so come on, write down this three reaction. For I minus, write down H2S and write down the Cr₂O₄ 2 minus. It's important. Write down the reaction. So what is this? You know, this is that mention over here. Write down all four. Chalo, write down all four. Mention over here when you add Cr₂O₄ 2 minus. 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 Come on, write down 4 equations, 5 equations, and done in the chat box. And it's done. Come on, everyone. Done in the chat box. Kevin is also done. Kevin, show me your book and pen. Why is it taking so much time? Book. Flip it. Okay, fine. Chalo. Let us go ahead. Yeah, let us go ahead. Now, let us move after the reactions, Kevin. Let us move to KMnO₄. Yeah. What is the color of KMnO₄? You must have seen it. KMnO₄. What is the color? What is the color of KMnO₄? Yes. One more color to apply on the hair. Yeah. What is the color of KMnO₄? Someone is saying pink. Someone is saying purple. Okay. Let me show you how does your KMnO₄ look like. Actually in between, you can say, like it's very, very dark purple. It is very, very dark purple. Like if you like, let me show you, if you put it in the water, you will see the actual purple. Yeah, it is like this. Okay, not pink, but not pink. We can say it is violet or purple, isn't it? Not pink. Pink is like, if you put it in the aqueous medium, it appears to be pink. Like, let me show you. How does it look like if you put it in the aqueous medium? See, this is how it looks like. Not exactly pink. Can we call this as pink? Do not tell me I am colorblind. I cannot identify pink. Is that pink? No, na? I hope I am not a colorblind. Yeah. Otherwise, I'll get to know today that I am a colorblind person. Yeah, it happens. It happens. You know. Anthony, what color you can see? Tell me. Let's check if you all are not colorblind or am I colorblind?
Sir, like purple or violet, sir.
Purple or violet? Ah, okay. Thank God I am not colorblind. If I am colorblind, then even Anthony is colorblind now. After titration, it will be pink. I said. Okay. Fine. You must have done the titration of this, isn't it? That's why this pink is coming. You know, like in laboratories, I might have told you this. Like our teachers, like you all must be having manual. Yeah, give me yes or no. You all must be having manual. Yeah, what we do? We look at the manual. Yeah. Oh, 5 ml. Yeah, exactly 5 ml. Not even 4.9, not even 5.1. And we get that pink color and we do not know, oh my God, is this pink really pink? Yeah. We ask all our neighboring friends. Yeah. Is this pink? Can you see this pink? Isn't it, Sarjana? Yeah. Is this pink? I think this is pink. Then you feel that no, this is lighter. Let us add 1 or 2 more drops. Yeah. And it becomes, oh my God, this is the pinkest pink. And the teacher sends you back. We did not want this pink. Yeah. Isn't it, Anmoldeep? Oh my God, this is a pink. Oh my God. This becomes pinkest pink that we have ever had. Yeah. That happens, isn't it? So our teacher used to say, you are not here learning science. Okay. You know what we do? I must have told you this. No? I've told you this. We do not learn science in the laboratories. What we do, Anmoldeep? We do the cooking. Yeah? It is a cooking class. Just like in cooking, Kevin, you have written over there, put 2 grams of salt. Yeah? So we take the 2 gram of salt in our food. Isn't it, Anmoldeep? Similarly, 2 gram of KMnO₄. Exact 2 gram of KMnO₄. Not even 1.9, not even 2.1. Yeah? We do not know what happens if I take less and what happens if I take more. Exactly, it is given 2 gram means it should be 2 gram. Okay, this is given 2 gram. The color should turn pink. The color has turned pink. We have got our answer. Yeah, similarly in food also. Oh, this color, oh, nice color. Okay, this is our food, isn't it? Yeah, that is exactly what we do in the laboratories. You know what I now already your September is going on now, no use only, but you know, trouble your teachers in the practical. I know it is like you have too many students, and too many students you have like 1 or 2 teachers, isn't it? They'll explain you in the beginning, okay, this is this, and you go and perform. Tell them, ask why you think, why if I'm adding more drops and more leaf, why I am adding more, while I add more drops, why it is becoming darker pink, not lighter pink when I add more drops? Why not it is changing color? Why only pink color? Why not green color? Yeah, this is all question you should ask. Yeah, the teacher gets good salary. Yeah, it's a government job. He or she gets good salary. Trouble them. Ask questions in the lab. Yeah, like do not just, oh, pink color is given. I've got pink. I've got answers. No, trouble them, but do not trouble in the practicals. Okay, in the practical exam, or they will trouble you. So do not trouble them in the practical exam. Trouble them in their normal practicals. Yeah. Okay. Anyways, let us come back. Okay. So K₂Cr₂O₄, how did we prepare? We took the ore, that is chromite ore. From the chromite ore, we had got chromate. From the chromate, we got sodium chromate. From the sodium chromate, we got the potassium dichromate. Yeah. I'll repeat. We got the chromite ore. From the chromite ore, we got the sodium chromate. From the sodium chromate, we got sodium dichromate. From sodium dichromate, we got the potassium dichromate. That is how we prepared potassium dichromate. Kind of same. Over here, we have we want to prepare KMnO₄. KMnO₄ is called as permanganate. So what I'll do, I'll take a ore. The name of the ore, I always struggle to what we say, pronounce this. Pyrolusite. Yeah, pyrolusite. Pyrolusite. Whatever it is, write down the name correctly. pyralusite. I still struggle to say that name. I do not know why. I'm teaching from so long, but I always struggle to say the word name. Okay, pyralu, pyrolusite. This can be correct. Pyrolusite. Pyrolusite. That is your MnO₂. Now we do not have any other ore over here, so we do not have to remove that metal. Yeah. So one step is less. This is two-step preparation. This is two-step preparation. Okay. So what we are doing, we are converting your pyrolusite. This is correct. We are converting pyrolusite, that is MnO₂. We will convert it to potassium manganate. So again, same thing like over there we had treated with base and oxygen, yeah, to get the chromate. Over here we are treating with base and oxygen to give you potassium manganate. Okay, to get you potassium. Write down the first reaction. Write down the first reaction. Okay, we are getting. Write down the second also. Do not write the third. Write down the second, first and second. Make it dash and first and second. So from MnO₂, we are getting K₂MnO₄. MnO₂ is nothing but the pyro. MnO₂ is nothing but the pyrolusite. Correct. MnO₂ is pyrolusite. 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 Okay. Come on, write down the first reaction and done in the chat box. And remember, K₂MnO₄ is a green color compound. K₂MnO₄ is a green color compound. And it's done, and Moldip is done. Anthony is also done. Kevin is also done. Chalo. Let us go ahead now. So from MnO₂, what is the oxidation state of Mn in MnO₂? Come on everyone, quickly in the chat box. What is the oxidation state of Mn in MnO₂? Yes, what is the oxidation state? Very good, Sindhuja. You are late, by the way, today. I have noticed. Okay, so it is +4. So remember like this, Arjuna. Correct, Kevin? From +4, it is going to K₂MnO₄. Come on, tell me the oxidation state over here. Yes, Anmoldeep. Come on, Kevin. Sarjana, tell me the oxidation state of Mn in K₂MnO₄. Yes? Correct? It is 6. So as I told you, again, +4, +6, +7, again, are the common oxidation state of Mn. Yeah? So in the first case, we are going from +4 to +6. In the second case, we are going to go to +7 now. Look over here. So what we have got? We have got our potassium manganate. We have got our potassium manganate. Okay. From potassium manganate, simple. Yeah. We have K₂MnO₄. We do not want a K. We want to remove that K. So simple. What I'll do? I'll simply add the Cl2. Yeah, it will remove the K. Again, KCl, good affinity. Isn't it, Sarjana? So what will happen? One KCl will be removed. So that brings my potassium permanganate with the 7 oxidation state. +7 oxidation state. Come on, write down the first and write down the third reaction. In the third reaction, we pass the carbon dioxide. That is also one of the way to get our pyrolusite ore back and KMnO₄. Okay, pyrolusite ore again, which we can use. Yeah, write down the first and third reaction. These are the possible ways by which you can prepare potassium permanganate. You can prepare potassium permanganate. Come on, done in the chat box. Vivin, Sadhana, Anmoldeep. and please do not come for late for lecture. I was going to miss the word late. I was going to say, please don't come for lecture. Please don't come late for lecture. Sintuja, yeah, Kirtini, try to come on time. Even Anthony came a little bit late today. Anmoldeep was also 5 to 10 minutes late. Yes, Anmoldeep? Yeah? Chalo. Let us go ahead. Let us go ahead. Do not say sorry. Just come on time. You do not have to say sorry. You know, this is the common line of a teacher. I hate sorries. Yeah? Most of the teachers say that. I hate sorry. Why you have to say sorry? Okay, Sindhuja. Chalo. Let us go ahead. Yeah. Now this also. Manganate ion shows the disproportionation reaction. What is Sarjana? What is disproportionation reaction? What is disproportionation reaction? Kevin, Anthony, and what is disproportionation reaction? Yeah? What is disproportionation reaction? I'll give you hint. This is a disproportionation reaction in front of you. You have reaction in front of you. Now tell me, please. This is the another way to prepare MnO4 minus, that is KMnO2. For the reactant is not the correct term. And yes, Sajna, Kevin. What is disproportionation reaction? Yes, it is in front of you. Ragul, Sindhuja, Kirtini, it is in front of you. The reaction is in front of you. What is this proportionation reaction? Look at it, Kevin, and observe. Look at it and observe. Check what is this proportionation reaction. I have given you the reaction itself. I am telling you to explain me. Anyone over here want to become a teacher? No, no, na Sindhuja? Yeah, no teacher. I am telling you, no, I was exactly the same. Exactly the same. I used to say I do not want to become a teacher because I do not want to study for my whole life. Yeah, teacher has to study the whole life. But I am telling you, it is a very cool profession. The days are gone where you have the old teachers, yeah, sitting with glasses. Your teacher is not wearing glasses. All of my students are wearing glasses. Yeah. So gone are those days where teaching was a, you know, was considered as a very different or a stereotype profession. We require young teachers who can, who can understand young people, who can understand them and make make them understand by understanding how they understand. Yeah, Kevin. So teaching is a good profession and it has good money also. I'm telling you, if you are a good teacher, you'll earn good money. Yeah, more money than your starting of your doctor career. Afterwards, obviously, afterwards it overtakes. Yeah, if you become a surgeon, a brain surgeon or something like that, then there is no, yeah, there is no barrier for the money to income. Yeah, I'll definitely visit you. I hope you are completing the whole syllabus of biology. You are studying the whole syllabus of biology. Yeah. Otherwise, I'll come with the, like, I am having neck pain. Sir, we omitted that chapter. You do not know how to treat neck pain. I'll treat you for hand pain. That's okay. Yeah. I hope that is not the case. Yeah. And you'll treat me for neck pain only. Oh, your neck is paining. Come, I'll press it. Yeah. Yeah. Hmm. Okay. Come back. MnO42 minus. What is this proportionation reaction? You must have done this in the school where you have learned your type of reaction. And do not say reactant. Okay, when you say reactant, for example, if I use the term reactant, over here I am talking about Mn as well as oxygen. Correct? You have written correctly, both oxidation and reduction occurs, but do not use the term reactant. When you use the term reactant, that means you include Mn as well as oxygen. So we can say that for the same element. Correct. So disproportionation reaction is a reaction where oxidation and reduction occurs of the same element. Okay, your Mn, look over here. Your Mn, what is the oxidation state over here? Plus 6. It is getting converted into MnO4 minus. That is nothing but plus 7. Then MnO2 you are getting. That is nothing but plus 4. So yes, plus 6 to plus 7. Is it oxidation or reduction? Sarjana, Kevin, and is it reduction or oxidation? Plus 6 to plus 7. Yes, it is nothing but correct Anmoldev, correct and correct Sarjana, it is oxidation. But when I go to plus 6 to plus 7, sorry, when I go to plus 6 to plus 4, Ragul, yes, what is it? It is nothing but correct Anmoldev, it is reduction. So over here, your Mn itself, it is undergoing oxidation as well as reduction, the same element. And that is your disproportionation. Yeah, that is your disproportionation. Yeah, it happens, no. Like you have got out of Kevin has got biology 100 out of 100 and chemistry he failed. So that is disproportionation. One out of one field. Yeah. It should not happen, or I'll come over then and I'll beat you. I'll take a flight ticket, especially I have your address from the TG campus. Yeah. I'll take the flight ticket personally and I'll come there and I'll kick you. It should not happen in the studies, disproportionation. So over here, disproportionation means what? Plus 6 to plus 7 plus 4. That means same element, your manganese, is undergoing oxidation as well as reduction. So when does this happen? When you put it in the acidic medium. When you drop your your MnO4 2 minus, that is your manganate. When you drop your manganate ion into acid, what will happen? It will turn it into MnO2 and potassium permanganate. Come on, write down this reaction. Important. Write down the reaction done in the chat box. Come on, write down the reaction and done. Write down the reaction and done in the chat box. So yeah, manganate, if you put it in acid, undergoes disproportionation reaction, gives you MnO4 minus and MnO2. So let us go ahead now. Let us go ahead. Yeah, let us go. Sure. Now another method is your electrolytic method. Now anode, does it undergo oxidation reduction? At anode what happens? Yes, Arjuna, Kevin and Anuldeep, Ragul, Kevin, Kirtini. At anode what happens? Oxidation or reduction? Yes. At anode, yes, oxidation happens. So what I'll take? Again, I'll take that manganate. Yes, your manganate, if I do the electrolytic reaction, what will happen? In the cell, it will go to anode, your MnO4. Yes, your MnO4 minus, MnO4 minus will get deposited at the anode as oxidation will occur, and at cathode, your hydrogen gas will be released. Yes, so I'll take K2MnO4, that is a manganate, do the reaction. Okay, and what will happen at anode? Write it down. You will get MnO4 minus at anode. Okay, mention that. Write down this anode and cathode. You will get MnO4 minus at anode, not the cathode. Okay, so it undergoes oxidation to give you MnO4 minus, Okay, and at cathode, hydrogen gas is released. Hydrogen gas is released. Hydrogen gas is released. Okay, hydrogen gas is released. Okay, now in the laboratories, this is what we do on the large scale. Okay, now in the laboratories at the small scale, we do not go and take the ore. Yeah, over here we have the Mn2 plus salt. Okay, easily available Mn2 plus salt. So we just we treat it with peroxodisulfate, and it will convert into, yes, it undergoes oxidation. So we use an oxidizing agent. So no matter what oxidizing agent you will use, your Mn plus 2, if you take plus 2, it will always convert into plus 7. That is how you have to remember. So plus 2 will convert to plus 7 always. You will take the Mn2 plus salt. So Mn2 plus salt, that is a manganese salt. If you oxidize it, over here I have used oxidizing agent, which is a peroxodisulfate. If you oxidize it, what will happen? Your Mn2 plus will get oxidized to Mn plus 7. Come on, write down the reaction. This is the laboratory preparation of potassium permanganate. Come on, write it down. Laboratory preparation of potassium permanganate. Now, what is laboratory preparation? Kevin, laboratory preparation means cooking. Yeah, what we do in the lab. What we do in the lab. Now, how it is different in the lab? You prepare it at small scale. Okay, so there are so many factors that you ignore. Even if you get large amount of byproduct or the waste product, it is still fine. Yeah, there is not much loss. But on the large scale, that some will become 1000 kg, 2000 kg, which is not required. Are you getting it? So commercially, it is very important that we do not get waste product. Otherwise, then, like most of the countries, do you know, like this chemical factories and all this, why they are in the second grade and the third grade country like Africa? Yeah, they have the maximum number because they get so much of waste product. You have to again treat that waste product to dump it in the ocean. But over Africa and everywhere, we do not have such rules. So they directly don't care what humans suffer. They directly dump it. Yeah. Sure. Let us go ahead. Now again, potassium permanganate, it is dark violet. We can say dark violet. Not purple, we can say dark violet. It is soluble, giving purple solution. It is soluble in water, will give you purple solution. It reacts with heat, it reacts with alkali. It is also an oxidizing agent. It is also a strong oxidizing agent. Okay, it is also an oxidizing agent. Okay, so let us look at it. So heat, again. Now over here, the spelling of manganate is little bit off. So please ignore that. Okay. So KMnO4, if I heat it, look over here. KMnO4, if I heat it, it will convert into manganate again. So as I told you, remember the common oxidation state. That is enough. Remember the common oxidation state. That is enough. Okay. Look over here. So over here also potassium manganate. Over here also, if I treat it with alkali, potassium manganate. No matter what happens, the common oxidation state you have to remember. Look over here. In alkaline medium, if I treat it, again what I am getting. So you have to remember like this. Yeah. Then and then only it is possible to remember this. Otherwise, it becomes very, very, very difficult. Okay. Very, very difficult. Sure. Let us go ahead. This reactions, go through it once. Not that required. We'll go to the important part. Okay, let us go to again KMnO4 and those reactions. Now again over here also it should be Mn. MnO4 minus. So this is what manganate ion. Please write it down. Mention it. Manganate ion, that is MnO4 2 minus. Yeah, MnO4 2 minus is green in color. tetrahedral green in color, MnO4 minus, that is potassium permanganate, it is purple in color. Please mention it. Please mention it. Yeah. MnO4 2 minus, it is green in color. MnO4 minus, it is purple in color. MnO4 minus is purple in color. Okay, so please mention over there that it is purple and it is green. So KMnO4 2 minus, sorry, K₂MnO₄, that is a manganate ion. It is nothing but green, and MnO4 minus is purple. MnO4 minus is purple. Okay, just give me a minute, everyone. Okay, so where were we? Yes, MnO4 2 minus purple, MnO4 2 minus green, and MnO4 minus is purple. Okay, now look over here. Let us go to little bit of your compounds. Just a minute. Now, so your potassium permanganate, the important part are the reactions. Okay, the reaction part. Let us go to the reaction part. Just a minute. Let us see the reactions of potassium permanganate. Just a minute. We have lanthanide and actinoids also. I doubt that we will be able to finish today. It is not written. Okay. So anyways, I'll tell you. Potassium permanganate, how does it behave in acid and in neutral solution? Okay. Now, as just now we discussed, potassium permanganate is what? Potassium permanganate, it is also an oxidizing agent. Yeah. Your KMnO₄, it is also an oxidizing agent. Yes or no? Yeah, it is also an oxidizing agent. So your KMnO₄ will behave as an oxidizing agent no matter what. For example, look over here. How it will behave in acid solution. Give the heading reactions. Give the heading reaction in acid solution. Don't worry. Do not make those faces. I am going to give you break after 5 minutes. Okay. In acid solutions. Okay. So how will it behave in acid solution? Suppose I have iodide. Yes, I have iodide. So if I treat iodide means I minus. So if I treat iodide with your KMnO₄, I am writing the ionic reactions. Okay. When I write Ki, when I write I minus, that means imagine I have Ki or NaI. Okay. I am writing ionic reactions. So I minus, if I treat it with KMnO₄, that is your permanganate. So let us write MnO₄ minus. And as I am telling you, it is an acidic medium. So always and always remember, no matter what, your MnO₄ minus is your oxidizing agent. Sarjana, oxidizing agent means it reduces itself. So always and always it will reduce itself to Mn+2. Close your eyes and write Mn+2. Do not literally close your eyes and write, otherwise you will write it on some other place. Okay. What I mean is, it is confirmed it will be always, Anthony, look over here, it will always be +2. Okay. So if it is an oxidizing agent, if it is oxidizing the other substance, it will be +2. Similarly, I minus will oxidize to what? Yes, I minus will oxidize to Kevin, Sarjana and Anthony. I minus, if I oxidize it, yes, correct, it will become I2. It will become I2. Okay, it will become I2, and your H plus will give you water. Remember like this. It's okay if you do not remember the balancing for your NEET exam, but for board exam you have to remember. But I guess now in NCRT, no, DNF is there. DNF is there. Okay. So that is how it will behave. Now, no matter what, over here I have taken I minus. Similarly, let us take Fe2 plus. Yes. Fe2 plus will oxidize to what? Yes. Fe2 plus will oxidize to what? We have seen. What is the other common oxidation state? Sarjana, Kevin, Prasanthi, Anmoldeep. Yes. Kevin, what was it? Other oxidation state. And yes, correct. Yes, other oxidation state of Fe plus 2. It goes in Sarjana. If I oxidize Fe plus 2, Kevin, what it will go to? Come on, not that difficult. Fe plus 2 will go into Fe plus 3 no matter what. Are you getting it, Kevin, Anmoldeep, Sarjana, and so Fe plus 2 will go in Fe plus 3, MnO4 minus, again Mn2 plus, your H plus, again Sarjana will give you H2. Are you getting it? Yes or no? Yeah, I know it is little bit boring, but we have to do it. No option. Yeah, okay. Similarly,
Sir,
okay, can anyone tell me what is this?
sir,
Yes,
so can you explain again, sir?
yes, Anthony, look over here. So what did I tell you, Anthony? Your MnO4 minus is oxidizing agent. If you calculate the oxidation state, this is plus 7. So no matter what, your plus 7 will get convert to plus 2, no matter what. Always and always it will get converted to plus 2. And since it is an oxidizing agent, Anthony, it oxidizes Fe2 plus to common oxidation state of Fe, that is plus 3. Okay, so always and always we will get the plus 3. Simple. Okay, simple. Is it clear, everyone?
Yes, sir. Thank you, sir.
Is it clear? Come on, give me yes or no. Okay. Chalo. Let us take a break. Yes, let us take a break. We'll do this after coming. Okay. Go drink water. Wash your face. Okay. We'll continue at 8:09. Okay. Please come back sharp 8:09. Yes, everyone, back in the chat box. Come on, back in the chat box, everyone. Turn on your camera. Sarjana, Kirtini, Sindhuja, Prasanthi, Anthony, Kevin. Turn on your cameras, everyone. Come on, back in the chat box. Is everyone back? Yes, Anmoldeep has turned on the camera. Prashanthi, I'm turning on the camera. It's okay. Prashanthi, Anthony, Kirtini. Sure, let us begin. Okay, let us begin. Now, over here, how? I asked you something. Yeah, C2O42 minus. What is this? Anyone? Yes, Arjuna, Kevin, and Prashanthi, Ragul, Gopinath, Kirtini. Okay, Kevin. Okay. So tell me one thing. What is this? Yes? Okay. What is this? Sarjana? Organic chemistry? Yes? What is this? Okay. Yes, Kevin, what is this on your screen? Ragul, Gopinath, Anthony, Sindhuja, Prashanthi, Kirtini. Or do I have to take everyone's name or what? Come on, tell me, what is this? What functional group is that? Come on, at least tell me that. Yes, and that is correct. I'm asking the others. What functional group is that? Yes? Oh, OH. OH functional group. Oh, Anthony, no, not OH. Okay. They are carboxylic acid, correct? Is that carboxylic acid? Correct, carboxylic acid. So when you join two carboxylic acid, this is your simple carboxylic acid, the most simplest dicarboxylic acid. This is the most simplest dicarboxylic acid known as oxalic acid. Okay, known as oxalic acid. Okay, so if I remove the H plus of those, COO, COO, if I remove the H plus, it becomes negative, negative, we call it as oxalate ion. Ion. Okay, from oxalic acid, we have got oxalate ion. So I can write this as C2O4 2 minus. Is it clear, Sarjana? Is it clear? Yes. Prashanthi, Kevin, is it clear, Anthony? This is nothing but your oxalate ion. From the oxalic acid, you have removed the proton, you have got the negative charge, and that has given you oxalate ion. Clear? So again, I have taken the oxalate ion. Okay. So C2O42 minus. Yes. If I have taken, I have MnO4 minus. Okay, MnO4 minus again in the acidic medium. So again, if I have acidic medium, yes, everyone, reply in the chat. Minus will convert into what? MnO4 minus. Sarjana, in acidic medium, no matter what you have, MnO4 minus, your Mn will convert into Kevin, Anthony, Sarjana, your Mn will convert into what? Ragul, Gopinath, Anmoldeep, your Mn will convert into no matter what, it will convert into correct, Anthony. Yes, Sarjana, what happened? Look sleepy. Come on, wake up. It is Mn2 plus. It is Mn, Mn2 plus. Yes, Mn2 plus. What time you all have come from school today? Yeah. Archana, what time did you come home from the school? Now everyone will write 6:30. See, everyone will write 6:30. I know. Yeah. What time did you come home, Archana? 3:40. You must have even slept for an hour. 6:45. Okay. I'm waiting for the time 6:59, sir. Hmm. Look at our struggle. Yeah. Okay. Look over here. Mn will get converted no matter what to Mn2 plus. Your C2O4 2 minus, since it contains carbons, if it contains oxygen, it will convert into carbon dioxide. From yesterday to Monday holiday. Carbon dioxide and H plus will convert into H2. Simple as that. Simple. Okay. Similarly, other reaction, suppose I have S2, that is your H2S. Anyone have taken the smell of H2S? Yeah. Sarjana, Kevin, and Prashanti, Anthony. Anyone? Sindhuja, H2S. Do you know how does it smell? Anyone has experienced the H2S smell? Yeah. Yes, correct. It is rotten egg smell. Imagine. Already it has a smell of egg. That is already yuck. Yeah. That is already not good. With yeah. Now imagine it is rotten. It is spoiled. Yeah. Rotten egg smell. Yeah. So H2S has a rotten egg smell. Okay. H2S. We are writing what? We are writing ionic reaction. So I'll write H2S instead of H2S. It dissociate into what? S2 minus. Okay. So I'll write S2 minus. Now same thing over here. If I am taking Sarjana S2 minus, yes, Kevin, if I am taking S2 minus, I am treating it with MnO4 minus. That is nothing but KMnO₄ in the acidic medium. No matter what, Anthony, Kevin, your Mn Prashanti will get converted into what? It will get converted into Mn plus 2. It will get converted into Mn plus 2. S2 minus will get oxidized to give you the sulfur precipitate. Your sulfur solid will form, and also your H plus again will get a water. Come on, write down the reaction. Yes, if I treat KMnO₄, that is your potassium permanganate, with yes, with H2S, it will get converted into Mn plus 2 and sulfur precipitate. Sulfur precipitate. Come on, write it down, everyone. Come on, write it down and done in the chat box. Write down the C, D, both the reaction. Pressure C. Write down both the reaction and done in the chat box. Come on, done in the chat box. Write down both the reactions. Come on, done in the chat box. Okay, sure. Let us go ahead. Let us go ahead now. Your H2S. Yes, we have done this. Let us go ahead now. Okay. Now after this, write down one more reaction. Okay. So your H2S is done. Okay. Then what we have? Then we have SO3 2 minus. Again, same thing. In organic chemistry, everyone, what do we mean by oxidize? Like, what do we mean by oxidation in organic chemistry? Yes, what do we mean by oxidation for organic chemistry? Prashansi, Kevin, and Sarjana, Rakul, Gopinath, Kirtini. Yes, for organic chemistry, if I ask you, how do you define oxidation for organic chemistry? Yes, correct. Addition of oxygen, removal of hydrogen. Perfect. Addition of oxygen or removal of hydrogen. So similarly, same thing over here, this minus will get converted. If I add another oxygen, it is undergoing oxidation. Again the same thing. Yes, and no matter what, as I told you, acidic medium MnO4 minus, it will get converted into Mn plus 2. Mn plus 2, your SO3 2 minus, it will undergo oxidation to give you SO4 2 minus. It will give you SO4 2 minus. H plus again will give you H2O. Now write down the reaction E. Your SO3 2 minus also got oxidized. So these all are proof. These all are proof. Yes, that your KMnO₄ is acting as an oxidizing agent. It is acting as an oxidizing agent. It is acting as an oxidizing agent. Come on, done in the chat box, everyone. Done. Okay, sure. Now similarly, same thing over here. NO2, your nitrite, yes, NO2 minus, yes, again NO2 minus. If I oxidize it, again MnO4 minus, write it down please. Again H plus, it will oxidize to what? NO2 minus will oxidize to NO3 minus. Mn plus 7 again will give you Mn plus 2. Yes, your H plus will again give you H2O. Come on, write it down. I hope it is simple, yeah? It should be simple now. So remember like this, you'll get your answers. Okay? Remember like this, you'll get your answers. Otherwise, it will become difficult. Remember like this, you'll get your answers. Done. Everyone write down the F and done in the chat box. Okay. Sure. Okay. Now this was your KMnO₄ behaving in acidic medium. Yes, KMnO₄ behaving in acidic medium. Now what in the neutral or slightly basic? Neutral or slightly basic solution. Okay. Now look over here. In acidic, write it down. In acidic, it will always and always in acidic, it will go from plus 2 to plus, sorry, it will go from plus 7 to plus 2. In acidic, it will always go from plus 7 to plus 2. Okay, similarly in neutral or slightly basic, it will go from plus 7 to plus 4. Neutral or slightly basic, it will go from plus 7 to plus 4. Same thing again and again. Look over here. What is happening? You have MnO4 minus. Suppose I am reacting now. We are doing for neutral or slightly basic solutions. Neutral or faintly alkaline solution. Slightly basic solution. Okay. So what will happen over here? Your MnO4 minus, again everyone, I have taken MnO4 minus. Since it is a neutral medium, I'll have inside now. And suppose I have the iodide. Okay, I have the iodide I minus. Now as I told you, Prashansi, what will happen? Since it is a neutral medium, your plus 7 will get converted into what? It will get converted into plus 4, Kevin, and that is your MnO2. That is your MnO2. Okay, and I minus, again you have to add oxygen. It has become IO3 minus, and your H2O will convert into now basic medium. Okay, in the basic. Same thing Even if I say H2O3, even if I take H2O3 over here, look at that, write down both the reaction afterwards. You have MnO4 minus. If I take again H2O3, again neutral medium. So what will happen, everyone? Again your MnO4 minus, no matter what, it will convert into MnO2. Your H2O3 will convert into sulfate and again a basic medium. Again a basic medium. Okay, is it clear, everyone? Come on, write this down, and just give me a minute. I'll be back. Write it down. Let me bring my bottle. Write it down, everyone. Yes, everyone. Come on, done in the chat box. Can we go ahead? Yes. Okay. Now this brings the end to the D block. Yeah. This brings the end to the D block. Should we do some questions? Yeah. Let us do some questions from the D block. We have not done any questions though till now. Let us do some questions. The NEET PYQs. Yeah. Let us do some NEET PYQs. No? Let us solve some NEET PYQs first. Yeah. Okay. Now in the last lecture, if you remember, how many of you remember the magnetic moment formula? Yes. Prashanti, Kevin, what was the formula for magnetic moment? Yes. Sarjna and Ragul, Gopinath, Kirtini. Kevin, were you there in the last lecture? No. Anyways, look over here. The formula was to find out the magnetic moment. Do not miss the live session. I have told you so many times. Yeah, you miss everything, but do not miss the live session. Yes, n plus 2. Yeah, n was number of unpaired electrons. N was number of unpaired electrons. Yes, n is nothing but the number of unpaired electrons. Okay, number of unpaired electrons. Now, on the basis of this, chalo, let us solve some questions. Let us solve some questions. Let us solve some questions. Okay, look over here. Now suppose this is NEET 2020 question. Okay, NEET 2020 question. I want to answer quick. Okay. Chalo, come on everyone. I want everyone to solve this. Yes, Prashanti, Anthony. I want everyone to solve it. Very good. Very good, and very good, Sajna. As I told you, do not sit and solve the whole thing. If you have that number of unpaired electron, yes, you know the answer. Yeah, getting it, Sajna, N. Yeah, if you have that number of unpaired electron, that is the answer. Simple. Yes, Kevin, come on, solve it. Yes, Prashanti, Kirtini, Sindhuja. Yeah. Chromium, what is the atomic number of chromium? Kevin, Prashanti, Anthony, what is the atomic number of chromium? Yes. What is the atomic number of chromium? Kirtini. Kevin, what is the atomic number? It is not 26, Kevin. It is Eventually it is 24. So it is 4. If you write down the valence electronic configuration, it is 4s2 3d4. It is 4s2 3d4. But what they have told us, you do not have Cr, you have Cr2 plus. So if I have Cr2 plus, yes, so over here one electron will jump, yes, one electron will jump from S to D, correct? So it is 4s1 3d5, yeah, 4s1 3d5 for the stability, correct? So Cr2 plus, 2 electrons you have to remove. If you remove the 2 electrons, what you will get? 4s0 3d4. So number of unpaired electrons, if I have d orbital, how many d orbitals we have? We have 5 d orbitals. So if there are 4 electrons, obviously they cannot be paired. 1, 2, 3, 4. So how many unpaired electrons we have? We have 4 unpaired electrons. We have 4 unpaired electrons. So we have 4 plus 2, that is 6. Yeah, 6 4s are 24. So root 25, root 25 is somewhere around 5, isn't it? So it is 4.9. Is it clear, everyone? Anthony, Kirtini, is it clear? Okay, now look at this. Now look at this. This NEET 2019 question, as it is what we have done. As it is what we have done. NEET 2019 question. NEET 2019 question. Come on, look at it. Just now we have done it. That will show you how much you were paying attention. Yes, Archana, Tiffany, Ragul, Kevin, you have written down it. You have written down the reaction. Yeah? If you treated with potassium iodide, that is your I minus. If I treated with, yes, MnO₄ in the neutral medium, what do we get? MnO₄ will convert to what? It will convert to +4, that is MnO₂, and I will convert into IO3 minus. Are you getting it? Why your reactions are important, not that difficult. Look over here. Just now we have done it, no? Yeah, just now, last reaction itself. See? Isn't it? Straightforward. As it is, they have picked it up. As it is, they have picked it up and they have asked in the exam. So that is why I am saying, if you do the reaction from NCRT, you will get it. Definitely you will have at least one reaction from there. Okay? Now come on, solve this. Yes, we did this in the last lecture. If I'm not wrong. Yeah, we did this in the last lecture. I told you, be smart and solve that. Yeah, be smart and solve. Okay, if you solve the fourth option, you'll get your answer. Yeah, if you solve the fourth answer, be smart and solve it. In the exam, do not sit and solve each and every option. If you solve the fourth one, see, fourth is 3, 1, 4, 2. Okay, if you get the fourth, you'll get your answer. Come on, solve the fourth one, Kevin. Many of you were not there in the last lecture. Come on, solve it. Come on, solve it. Yes, what is the answer, Kevin? I expect an answer from you for this. What will be the option, Kevin? Give me the option. Give me the option. Option A, B, C. Correct? Yes, Arjuna, what is the answer? A, B, C, D. Yeah, it is A, B, C, D. Yes, it is Ni2 plus. Yes, Kirtini, what will be the answer? Ni2 plus. What is our formula? N plus 2 under root. Yes. Ni, Kirtini, what is the atomic number of Ni? Yes, Gopinath. Prashanti, what is the atomic number of Ni? Yes, and what is the atomic number of Ni? Arjuna, atomic number of Ni? Yes, it is nothing but 28. It is 28. Yeah, 28. If I write down the valence electronic configuration, it is 4s2 3d8. 4s2 3d8. Now again plus 2, that means I have 3d8. So 4s0 3d8. So 3d8, 8 electrons, 8 electrons, 2, 3, 4, 5. So 8 electrons, how will I put the 8 electrons? 1, 2, 3, 4, 5, 6, 7, 8. So in the option, in the question, in the formula, we do not have this n as number of electrons. It is number of unpaired electrons. And how many unpaired electrons we have? We have 2 unpaired electrons. So 2, 2 plus 2, that is 4 to the root 8. Root 8. So Ni2 plus root 8. Okay. So root 8, where is it? Yes, option C. Is it clear, Anthony? Come on, give me yes or no. If it is not, please tell me. Is it clear? Maximum chance of this question
Sir,
to come. Maximum chance.
sir,
Hmm.
sir, like how that root 2 plus 2, can you explain again, sir?
That is the formula, Anthony. N plus 2. This is how we find the magnetic moment. What do we find? Magnetic moment. Under root n plus 2. Anthony, n is nothing but number of unpaired electron. N is nothing but number of unpaired electron. Okay, so when I have done nickel, atomic number is 28. But they have asked us nickel 2 plus. So whenever you get positive charge, Anthony, that means you are going to remove the electron. Correct? So from this, I have 2 positive charge, means I'll remove 2 electron. So 2 electron, I have removed it from the S. First you have to remove it from 4s, then only you have to go to 3d. So I have removed it from 4s, it has become 4s0 and 3d8 as it is. Then D, we know that, Anthony, in the D we have 5 orbitals. 1, 2, 3, 4, 5. Okay, so fill the 8 electrons. We will fill the electrons 1, 2, 3, 4, 5, 6, 7, 8. So how many unpaired we have, Anthony? We have 2 unpaired. Is it clear, Anthony?
Yes, sir.
Or give me yes or no?
Yes, sir. Thank you, sir.
Okay, sure. Then what we have? Okay, now do this. This was pretty easy, but come on, do this now. Yes, very easy. Come on, quickly. Yes, correct, Kevin. Anthony, I want you to solve it. Come on, solve it, Anthony. Sarjana, what happened to you, Sarjana? Come on, solve this. Not that difficult. Question Steve. I'll wait for 2 minutes. Come on, solve it. Correct, Sarjana. Anthony, I'm waiting for your answer. Come on, solve it. Those who have solved those, you move to this question. NEET 2018 question. Okay, NEET 2018 question. Come on, those who have solved the left one, move towards right one. Come on, solve it. Come on, everyone, solve it. Come on, solve it. Yes, Anthony. I'll teach you just a minute. Okay, look over here, Anthony. What is the question? The magnetic moment they have given you. The magnetic moment they have given you. Kevin, A for what? Left or right one? Okay, look over here, Anthony. They have given magnetic moment. Just now I told you magnetic moment. That means what? N plus 2. They have given the value. N plus 2. They have given the value 2.84. So they are asking you, Anthony. They are asking you that which of the following element shows this 2.84? Kevin, stick to one answer. What is this? A, C, D, everything. Write down B also then. Look over here, Anthony. Magnetic moment N plus 2, they have given 2.84. So they are asking that which of the element shows the magnetic moment 2.84. Okay. So and Anthony, if I check for Ni2 plus, okay, Ni2 plus nickel, what is the atomic number? Anthony, nickel atomic number is 28. Correct. So just now we had calculated for nickel, Anthony. What did we get? We have got under root 8. Yes. Just now we did it for nickel 2 plus, no? We got it under root 8. So under root 8 means what? Under root 9 is nothing but 3. So under root 8 is somewhat 2.89. Yeah. So it is. Are you getting it, Anthony? You have to solve it. You have to solve it and you have to check out of all these 4, which one you are getting is 2.84. Is it clear, Anthony? Okay. Yes. Now to the right. To the right. Come on. Again, once again in the chat box, what is the answer for the right one? Once again in the chat box. Once again in the chat box, what is the answer for right? Correct time. What is the answer for right, Sarjana? Yes, what is the answer for right? Paramagnetism, Sajna, what do we mean by paramagnetic? Yes, Sindhuja, Kirtini, Gopinath, Kevin, what do we mean by paramagnetic? Yes, correct. It should have unpaired electrons. That is the basic necessity of paramagnetism. Yeah. So over here, what is the oxidation state? We have MnO4 minus, it is plus 7. Yes, if you calculate, it is plus 7. So Mn plus 7 is what? 4s0, 3d0. Cr₂O₄ minus, what is the oxidation state of Cr₂O₄ minus? What is the oxidation state over here? It is plus 6. Plus 6 means what? Charge na. Again, 4s0, 3d0. Again, Cr₄O₄ minus, what is the oxidation state? Again, 4s0, 3d0. Yeah. Then we have MnO₄ minus with the oxidation state plus 6. So plus 6 means what? 4s0, 3d1. So only one option with the unpaired electron. Only one option with any electron. Forget about unpaired electron. Only one option with the any electron in the d block. Yes, so it will show DD transition. It will show paramagnetism as well. Is it clear? Come on, give me yes or no. Is it clear? Sure. Let us go ahead. Okay. Sure. Let us go ahead. Let us go ahead. Now look at this. Now tell me. Now do this question. Okay, do this question. F block will do it in the. Will start it in the next lecture only. Then we'll do the class assessment and we'll stop. Okay. F block in the next session, and next session I will solve questions. Okay, so please revise and come. Okay, this. Let me give you the option. Just a minute. Okay, this is the option. Come on. Come on. Color. I am giving you hint. You should know who shows color. Yeah. What is the reason for color? We have discussed. We have discussed what is the reason for color. Okay. That is a hint. Okay. Yes. Come on. Correct. And Sadhana, what is first of all discuss with me? What is the reason for colors? Yes. Prashanti, Kevin, Sadhana, Ragul. What is the reason for color? Anthony. We discussed this. Yeah. Why do we see color? Yes. In the last lecture we had discussed this. Isn't it? Sadhana, what is the reason for color? Presence of unpaired electron, DD transition unpaired electron, DD transition unpaired electron. So you have to check in which of the options there is a presence of unpaired electron. Come on, check. Come on, Kevin, check. In which of the options you have unpaired electron. So as I told you, it is very important to remember the periodic table. At least 3D and 4D you should remember. Over here they have given you the atomic number. It is 100% possible they may not give you atomic number. 100% possibility they may not give you atomic number. I am again telling you. Very good answer. Yes, Arjuna, I am waiting for your answer. What is the answer? Yes, what is the answer, Sajna? Yes, what is the answer? Just a minute. Yes, Sajna, what is the answer? Correct? Yeah, it should be. If I have Ni2 plus, again I am not going to calculate. Yeah, how many unpaired electrons we had got, Anthony? We had 2 unpaired electrons. Yeah, not I am not again going to write down 28, 4s0, 3d8. Yeah, 2 unpaired electrons. Then we have, let us solve titanium. Correct, let us solve titanium. Titanium is what? Scandium, titanium. Titanium, what is the atomic number? It is 4s2, 3d. So if it is plus 3, and it is 4s0, 3d, 1. So we have 1 unpaired electron. We have 1 unpaired. Are you getting it? Yeah, 1 unpaired electron. That's why answer is. Is it clear, Sarchna and Prashanti, Anthony, Kevin? Is it clear? Is it clear, Prashanti? Show some response. Do like this at least. Okay, I can understand too much of theory for today. Don't worry. After this, your F block is little bit left that we are going to start with coordination. Coordination is bit interesting. Okay, not like a D and F block. It will be bit interesting. Okay. So let's do this last, then we'll move to the class assessment. Let's do this last question, then we'll move to the class assessment. Okay. Now when you solve it, till I'll assign the class assessment. Okay, very good. Come on, everyone. Good, Kevin. I'm assigning the class assessment. Just a minute. Okay, very good, Anne. Very good, Sarjna. Very good, Kevin. Yes, Anthony. Colorless means what? You do not want any. You do not want any unpaired electrons. Yeah. You do not want any unpaired electrons. Yes, you do not want any unpaired electrons. That is the meaning of colorless. Yeah. So over here, scandium 3 plus. Anthony, if I solve it, yes, scandium is what? 21. So it is 4s2, 3d1. Yeah. So if it is plus 3, it will become 4s0, 3d0. No unpaired electron, no color. Yes, Ajna, getting it? So it is colorless. Scandium 3 plus. Okay. All of the other will have unpaired electron. Okay. So I hope it is easy. Yeah.